So in this video, we are going to look at, we are going to solve some of the problems based on NFA construction. So remember, the construction of NFAs is considered to be much easier compared to the DFA construction. So what we are going to do is we have done a lot of problems on DFA construction. And now what we are going to do is to do similar problems for NFA construction. So you can actually compare the DFAs and NFAs once we have done these problems. So what we are going to do here is that we are going to start with very simple problems first, and then we will proceed to more complicated problems. So most of the problems that we are going to discuss here is about designing NFAs for binary strings with a particular condition. Okay, so the first thing that we are going to design is for binary strings starting with a 0. Okay, so let's get started. So let the starting state be Q0, and from Q0 the condition is that it should start with a 0, right? So I can just write that that symbol 0. 0. I expect I expect that the string should start with a 0, right? And from Q0, if you see a 0, then you can go to Q1, and from there it is possible to have any transitions. So you can define 0, 1 to the same state itself, and Q1 by itself is going to be the final state. So this is the NFA for strings, for accepting binary strings starting with a 0. Now let's for comparison, let's draw the DFA as well. So if you want to draw its equivalent DFA, it will be something like this. So you start at Q0. Actually, you can pause the video here and then try to do it on your own, and then compare your answer. Okay. So anyway, so upon getting a 1, the DFA should never accept a 1 as an initial character. So upon getting a 1, it should actually go to a dead state. Okay. So let's say QD is a dead state. So if you get a 1, this should be going to a QD. And if you get a 0, so you make a transition to say Q1. Okay. And from there, you're not worried about what you get after that. So this is going to be your final state because you have seen a 0, and after that you can get anything. So anything like 0 or a 1, right? So this is going to be your DFA. And look at how simpler NFA is compared to the DFA. Okay, so we are only representing the essential information here. Okay, so this is our NFA and this is our DFA. Okay. Now, if you look at this NFA, the transition of Q0 on 1. If you look at the transition of Q0 on 1, it is actually not defined. It is actually mapped to the null set. Okay. So whereas here in the case of your DFA, Q0 on 1 is actually mapped to, the transition is all defined. It is defined to a dead state. So here the mapping is to a dead state. So that's equivalent to the null state here. Okay, that's very important. That's something which you need to understand very clearly. Now let us design for accepting binary strings that start with a 0, 1. Okay, so the idea here is that you can start at Q0 and then you have to just define 0 and 1. Okay, so upon seeing a 0, you go to Q1. Upon seeing a 1 from there, okay, you go to Q2. Okay, and then you are not bothered. Okay, this is going to be a final state, and from there, if you see a 0 or a 1, it's okay. So again, here we have only defined the essential transitions. If you look at here, Q0 to 1, Q0 on 1 is not defined. Okay, similarly, Q1 on 0 is also not defined. And this is enough for this definition is enough for an NFA. Whereas in a DFA, you should show all the transitions for all symbols, right? So we'll look at another question. So in this question, we are asked to accept strings that start with 0, 1, 0. It's also very similar to the previous thing. The only thing is you should draw 4 states. Starting at Q0, you define transitions like the same order which is given in the question. That's going to be 0, 1, 0. So if you see a 0, you go to Q1. From there, if you see 1, then you can go to Q2. From there, if you see a 0, then you are at Q3. Okay, and from there you can see any symbol, because you just want to start with 0, 1, 0. Okay, so from there it's possible to see any symbol. So this is going to be the NFA, which will accept strings that start with 0, 1, 0. So imagine if you are drawing a DFA for this, all the transitions must be defined. You can actually compare. I think we have already done this problem in the when we did DFAs, when we constructed DFAs. You can actually go there and compare, or even you can try to draw by yourself and compare this with this NFA. So let's move to the next one. So this is also a very similar question. You want to design an NFA for accepting strings that starts with say AABB, where the alphabet set is A, B. Okay. So instead of A, B, it can be also asked on a binary string like 0011. This question can be alternatively asked for if the alphabet set is 0, 1, right? So let's design for this question AABB. So let's start at Q0. So it's going to be very easy. Q0. Upon seeing an A, you can go to Q1. So if you see again an A, then you go to Q2. From there, if you see, you have to see B to proceed further. So if you see a B, then you can actually go to Q3. From there, if you see again a B, you are at Q4. And from Q4, you can see anything. So the only condition is it should start with AABB. So from here, you can start seeing anything. Okay, as simple as that. So we have seen questions for starting with a particular pattern. So now we'll look at questions for ending in particular pattern. So let's look at the first one. So ending in 0. So for accepting binary strings ending in 0. So this is going to be very easy. So you start at Q0, and you can see anything. Okay, you can see anything. Okay, so you should never forget to put the starting symbol arrow here. Okay, so this is very important. I forget it many times. So if you find such mistakes in the video, take it for granted that starting arrow is there. Okay, so from here you can for ending at 0, you can see anything from you have to see a 0 here. Okay, and then you can be at Q1. Okay, and remember, Q1 is going to be your final state. It's going to be your final state itself. So again, one important thing, very importantly, you should not give any transitions on Q1. Okay, if you give something like this is going to be wrong, because if you suppose if you're at Q1 and then if you are accepting any pattern of string after that, then how can we make sure that it ends at a symbol 0? So very importantly, you should not provide any transitions here. So we might get a confusion that what is wrong if I give a 0 transition alone here? I mean, that's true. Even if you give a 0 transition, still this NFA will accept all the strings ending in 0. But that's not essential. So our purpose is to express it in the minimum possible way. So even if you don't show this transition on 0 back to Q1, even if you don't do that, it will accept all the strings ending in 0. Because for an NFA to accept a string, it requires only one branch. It requires only any one of the possibility of parsing that string. If it stays Q1, then that's going to be getting accepted. So this representation, showing this 0 transition to its Q1 itself is actually not required here. So now let's look at this question. So for we have to find a constraint. So let's look at this question. We have to construct an NFA for accepting strings, binary strings ending in 0, 1. So we have seen exactly the same question earlier in our example in the previous videos. So anyway, let's go with the flow. So you start at Q0. You want to end with 0, 1. So if you see a 0, so you can see any pattern here. And subsequently, if you can get a 0 and then a 1, okay, and then that's it. Q2 is going to be your final state. From Q2, you don't have to show any transition. That's not at all required, right? So this is enough for representing an NFA. So we can actually make sure that this will accept that there is one way of accepting. There is at least one way of accepting any given string which ends with 0. Okay, so that's guaranteed. So give me any string that ends with 0, 1. I can show you a path where that string gets accepted in this NFA. So that's the key thing. So you can have many ways of not accepting a particular string, but there is one way that I can show that this gets accepted. So that's enough. That's enough for an NFA. So now let us look at this question. We want to design an NFA for accepting strings, binary strings ending with 0, 1. So this is very similar. So I need not explain it. I can just draw it Q0 and you can see anything. After that, at some point you decide to move further. And if you see a 0, you are at Q1. From there, again, don't forget to mark the starting state. From there, if you similarly here also. Okay, from there, if you see a 1, you can go to Q2. From there, if you see a 1, you can go to Q3. So you have a pattern of 0, 1, 1 now. And Q3 is going to be your final state. That's it. Okay. Now let's look at a problem which is of the type contains the substring. So contains the substring. So here we are asked to design an NFA to accept strings that contain binary strings that contain 0, 1 as a substring. So 0, 1 can occur in the front, middle, or in the end. So anyway, it is possible. So we have actually designed for these types of questions while we are doing the DFA construction. You can actually refer back to those videos. And this is going to be very easy for an NFA to be designed. So you start at Q0. You can have any choice of 0, 1. And in between that, you have to see a 0 and a 1, right? So Q0, and then you go to Q1. You have to see a 1. You have to see a Q2. You will be at Q2. And from there, again, you can see anything, right? 0, 1. So, and Q2 is going to be your final state. Okay. So this is going to be your NFA. So this is if you compare this with its corresponding DFA, this is very simple. Okay, the representation is very clear and very simple. Okay, so what if the string itself is 0, 1? Will it be accepted? Yes, there is one path. So from Q0. So what happens is that if you see a 0, you have the option of staying at Q0 or moving to Q1. So how this string is accepted? So from Q0, when you see a 0, it takes this path. And from there, if it finds 1, then it takes this path, and then your string is finished and you're at Q2. So this string is getting accepted. So give me any string which contains 0 as a substring. I can show you a path by which this string gets to Q2. That's the idea. So this is also a very similar question. Strings containing ABA as a substring, where the alphabet set is going to be A, B. Okay, so this is also very similar. You start at Q0, and from there you can actually see anything A or a B. So in between, you can proceed further. If you see an A, then you are at Q1. Then if you see a B, you are at Q2. And then if you see an A, you can be at Q3, right? And that's going to be your final state. And from there you can see anything, because this is going to be a substring. So remember, in the earlier slide, we dealt with ending with condition. Okay, so if you're dealing with ending with condition, NFAs with ending with condition, then you should not show a transition on the final state, right? 0,1 transition on the final state. That's not required. But whereas this is essential in the case of questions having the contains clause, okay, because that particular substring can be anywhere, okay. So the particular substring that you're looking for can be in the starting point, or in the middle, or at the end. So to consider all such possibilities, we should design our NFA like this. Now this question is little tricky. You have to design an NFA to accept binary strings that starts and ends with 0. Okay, so which are all the, you have to write, when the question is little tricky, you have to write you have to write all the possibilities starting from the minimum string that you need to accept. So here, if you get a 0, this has to be accepted because it starts and ends with 0. If you get a 0, 0, it has to be accepted, right? If you get a 0, 1, 0, it has to be accepted. If you get a 0, 1, 0, 0, this also has to be accepted. If you're getting 0, 1, 1, 0, this also has to be accepted. So these are some of the symbol strings which has to be accepted by our NFA. And remember, you have to note that you require only one path for accepting. At least one path is there, then that's it. That is accepted, right? Now let's start designing this. So if you see, so let's say I am at Q0. And if you see 1, 0, even if you see 1, 0, it has to be accepted. But even if you see 2, 0, it has to be accepted, right? So it has to start and end with 0. So it's starting and ending with 0. So it also has to accept strings like 0, 1, 0, 0. So our NFA should cover all such possibilities. So the condition is you need to accept strings that start and end with 0. So what you can do trivially is that you can draw a transition on 0 to Q1. And at Q1, you can see anything. Okay, 0, 1. And from there, you have to see again another 0 so that you are in an accepting state. Okay, so this is the trivial thing that you can do, right? Now there is a problem here. Okay, so the problem is that it will not accept 0, right? So to make 0 also acceptable, what we need to do is just draw a transition from Q0 upon 0 to Q2, right? So there are two transitions on 0 defined now. Now if you look at this diagram, so Q0 on 0, if you look at the transition function, Q0 on 0 is defined to both Q1 and to Q2. Okay, so So upon seeing a 0, you can either choose to go to Q1 or choose to go to Q2, right? And that's why it is called an NFA, right? So in a DFA, we cannot do this. In an NFA, since this is an NFA, that's the only reason why we can actually show two transitions for 0, right? So this is going to be an NFA having multiple transitions for the symbol 0. You can see for the symbol 0, we are having two transitions, one going to Q1 and the other one going to Q2. And this all happens just because it's an NFA. So let's move to the next question. So this is also slightly tricky. It says that we have to accept binary strings starts and ends with the same symbol. So it doesn't say that starts and ends with 0 or a 1. It is only mentioned that it has to be the same symbol. So all the strings that start at 0 and ends at 0 has to be accepted. Similarly, all the strings that starts at 1 and ends at 1 has to be accepted. So our NFA should be designed in such a way, right? So let's start design. Let's try to design this. So we should have two branches. One branch for accepting strings that start with 0 and ends at 0, and we should have another branch which will accept strings that starts with 1 and ends at 1. So let's try designing that. So if I have a Q0, so this is where I'm going to accept strings that starts with 0 and ends with 0. That's one possibility. Okay. From here I can see anything 0, 1, and again if I see a 0, I can be at Q2, right? So okay, that's one path. And from Q0 you can also start seeing 1, right? If you see a 1, then let's say it's Q3 here, and at Q3 I can see anything 0, 1. From there I have to see a 1. I have to see, so from there if I see a 1, I will get back to Q2. We can see that there are two paths, one in this direction. Okay, so this is one path. This path will accept all the strings starting with 0 and ending with 0. And similarly, we have another path here in this way, that is this path will accept all the strings that starts with 1 and ends with 1. Again, another very important thing that we should not forget here is that if your string has just 1 0, so this is also considered as starting and ending with the same symbol. So we don't have two symbols here. We have only just one symbol, and it starts and ends with the same symbol. So 0, if the string contains just one symbol, that's 0, this has to be accepted. Similarly, if your string contains only 1, that is the symbol 1 only for once, then this also has to be accepted. So these two strings containing just 1 0 or just a 1 has to be accepted. So we should have a provision to do that in our NFA. So what we can do here is that I can actually have a transition from Q0 to Q2, right, straight away upon 0 or a 1. So if you get a 0 or a 1, just one symbol, then you can directly go to the final state. So you can work out these 4 questions as the assignment for this video. Now the first question is the strings that start and end with different symbols. Remember, since it's a different symbol, we should have at least 2 symbols in our string, right? So we have already worked out for the problem having same symbols. Okay, so here we want to accept only those strings which starts and ends with different symbols. And similarly, the second question here is strings that starts with AA or BB, right? So where the alphabet set is A, B. So in the previous question, the alphabet set is 0, 1. And the third question is the strings that ends. So instead of starts here, we have ends here. So the strings that ends with AA or BB. And the last question is we have to accept binary strings containing the substring as 001. So we have worked out a couple of problems which are related to substring identification. So this is a very similar question, binary strings containing the substring 001. So all these questions are very easy. So all these questions are considered to be very easy. And since we have to draw NFAs, it's going to be much easier than DFAs. Okay.